operations and functions. Now, we have to take note that functions can be added, it can be subtracted, it can be multiplied or divided, just like the set of real numbers. So, we have here the operations and functions. Now, suppose we have two functions, let's say f and g. Um, these are functions with domains a and b respectively. That means that a is the domain of f and b is the domain of g. Then the functions f plus g, f minus g, f times g, and f over g are identified as follows. So all we have to do is to follow the formula or formulas. Now, if we are asked to find the sum of the two functions, let's say f and g, so we have f plus g of x, which is equal to f of x plus g of x. Now, the domain of the sum of the two functions is actually the intersection of the domain of A and the domain of B. Number two, if we are asked to find the difference of the two functions, f minus g of x. Now, this is equal to f of x minus g of x. Now, the domain of the difference of two functions is still the intersection of the domain of A and the domain of B. How about the product? F times g of x is equal to f of x times g of x, and the domain is still the intersection of the domain of A and the domain of B. Now, f over g, or f divided by g of x, this is given by the formula f of x over g of x, meaning we have to divide f of x by g of x, provided that g of x is not equal to 0, or x is in the intersection of A and B, and g of x not equal to 0, because if g of x will be equal to 0, the whole expression will be undefined. Okay? So to understand more on these concepts, we have here examples. Let f and g be two functions defined as f of x is equal to 1 over x plus 2 and g of x is equal to x over x minus 1. Now find the following and determine the domain in each case. So we have here an example for each case. So first case is the sum of the two functions. Now since we are given these two functions, all we have to do is just to use the formula. Now we are given the formula of f plus g of x. This is equal to f of x plus g of x, right? So by following the formula, f of x is 1 over x plus 2 plus g of x is equal to x over x minus 1. Then simplify this one. We have the LCD x plus 2 and x minus 1. So to come up with this expression, we have x plus 2 and x minus 1 divided by x plus 2. We have quantity x minus 1 plus quantity x plus 2 times x minus 1 divided by x minus 1 is x plus 2 multiplied to x. So we have plus x times quantity of x plus 2. Then simplifying the numerator, we have x minus 1. Then this can be equal to x squared plus 2x. Then combining like terms, we have x and 2x, so this is the 3x. So the simplified form is x squared plus 3x minus 1 over x plus 2 over quantity x plus 2 times quantity x minus 1. So that is now the sum of the two functions. Now this time, what is the domain of the sum of these two functions? Now we have to look at the denominator, since this function, the final function, is a rational function. And rational function is defined, okay, is defined as long as the denominator is not equal to 0. So in this case, the domain of this function, all real numbers except those values that can make the denominator 0. Now what are those values? So to know the values that can make the denominator 0, we should equate this one to 0, then solve for x. Now if we solve for x is equal to negative 2 and x is equal to 1, makes or make the denominator 0, right? So therefore, the domain is the set of values in the real numbers, okay, such that x is not equal to 2, negative 2, and x is not equal to 1. So this is our domain of the sum of two functions. Now, take note that this domain is also the intersection of the domain of A and B, because the domain of this, it is all set of all real numbers except negative 2, and set of all real numbers except 1, right? So if we uh, get the intersection or the commonalities of the two domains, then this is now the answer, which is the domain of the sum. Okay, now let's move on to the difference. So f minus g of x is equal to, the formula for finding the difference of the two functions is f of x minus g of x. So we just simply subtract the two functions, 1 over x plus 2 minus x over x minus 1. Then simplify again. So we have quantity x plus 2 times quantity x minus 1 divided by x plus 2. We have quantity x minus 1 minus x times quantity of x plus 2. Then moving on, so simplifying, we have x minus 1 minus x squared minus 2x. Then combining like terms, we have negative 1 or minus 1 minus x squared minus x, right? Or we can write that one into this form. Now, what's the domain of the difference? The domain of the difference is still what? The set of all real numbers except those values or real numbers that can make the function undefined or that can make the denominator 0. Now, we equate this one again to 0, then you solve for x. Then we come up with x is equal to negative 2 and x is equal to 1. Okay, so these are the values that can make the function undefined. Therefore, the domain of the difference of the two functions is set of all real numbers such that x is not equal to negative 2 and x is not equal to 1, which is the same to um, the domain of the sum of the two functions. Okay, next is the product of two functions. Now, f times g of x, okay, all we have to do is just to follow the formula. This is equal to f of x times g of x. So our f of x is 1 over x plus 2, and our g of x is equal to x over x minus 1. Okay, so we have to multiply both the numerator and the denominator. So 1 times x is x. Quantity x plus 2 times quantity x minus 1 is x plus 2, x minus 1. Therefore, the domain of the product is what? The domain of the product is the set of all real numbers except those values that can make the denominator 0. And again, it is still equal to negative 2 and 1. So these are the values that can make the function undefined. So therefore, the domain is the set of all real numbers such that x is not equal to negative 2 and x is not equal to 1. Okay, for the last case, we have the quotient of two functions. So how can we get the two quotient or quotient of two functions? F over g of x is simply equal to f of x times divided by g of x, right? Now, since we have fractions, rational functions divided by a rational function, then we can apply the concept on dividing a fraction, right? So this one, so we can now use the multiplication, the operation, which is multiplication, and we use the reciprocal of the divisor. So this becomes 1 over x plus 2 divided or times the reciprocal of this. So which is equal to x minus 1 over x. Then we multiply, and that is equal to quantity x minus 1 over x times quantity x plus 2. Now notice that this function here is not it's not defined if x is equal to 0, because if x is equal to 0, the whole denominator will be 0. And also, if x is not equal to negative 2. So what would be our domain? Therefore, the domain of this function is the set of all real numbers such that x is not equal to 0 and x is not equal to negative 2. Now, we have to take note that um, the domain of the quotient must be in the set of the intersection of the two domains. Now, again, this, if x is not equal to 0, it is still in the set of the intersection of the two domains. So therefore, this is the domain of the quotient of two functions. X should not be equal to 0 because this will be undefined, and x is not equal to negative 2, which is also which can also make the denominator to 0. Okay, so these are some examples on how to use the four operations of functions: the addition, subtraction, multiplication, and division. So thank you so much. So we have here practice quiz. If you want to know and if you want to practice, I have here a practice quiz. So all you have to do is to follow the formula that we have and also simplify. Okay, then find the domain. But again, it's optional. So if you want to know whether your answer is correct or wrong, you can show your answer in the comment section. So thank you so much. Hope you like this video, and do not forget to share the learning that you've got from this video. Thank you once again, and God bless.